First of all, I would like to thank SOFWERX for inviting me here. It's really an honor to speak about this important topic that is necessary to address because it's going worse and worse. Okay, I'm studying image and video forensics since I started my PhD in 2010 at the University of Florence in Italy, and I strengthened this topic during these years with many research experience abroad, and I would like to mention the postdoc research fellowship that I received from Australia government this year at the beginning of 2018. Today I'm with the Multimedia Forensic Lab in Florence, and this is part of a Center of Excellence of the university. My team is composed now by 4 people. Our skill is about, first of all, image and video forensics. And our background is from image and video processing and digital watermarking. We have some collaboration with IT forensic company for forensic consulting, and also some collaboration with Italian law enforcement, and with European Research Center. Of course, we constantly collaborate with the university, international university, for sharing knowledge and sharing ideas. We, as a group, we are involved in different projects on security-related issues, both for image and video forensics, and also for digital watermarking problem. This is an overview of my presentation. I would like to introduce a little bit the problem from my point of view, that is a technological point of view. And then I would like to show you some techniques that are able to solve or somehow try to solve this kind of problem, that is the weaponized information issues. Introducing you some case of study that we work on in my group in the past year, and more recently, very recently. And then I want to give you some new trends about countering deepfake and counter adversarial machine learning problem. So nowadays, as the other speaker introduced better than me, nowadays image and visual information is used to commit crimes at different level, from citizen level to national security level. So by means of different modalities and new aggressive behavior, this action can be different, can be very varied, from cyber terrorism, attack to personal reputation, and if you think about the personal level, the cyberbullying phenomena that is kind of important right now. And all these action can be perpetrated through social media and social network. This social network aspect, it's really important, especially when you have to deal with with fake news. Fake news is important from a political point of view when you have to deal with disaster and management of crisis. So it's necessary to contrast and to find tools able to deal with this kind of phenomena. When you talk about fake news, every time there are fake images associated, or at least images. And you have to understand if these images are related or not with that event. In this case, it's a really famous picture. Every time there is a flood in the US, in an hurricane, someone shared this picture about this shark in a street, in a flooded street. But this picture can be per se a fake. But it's important also to understand that this image is related or not with this kind of event. This is funny because this shark was from 2012 when there was the Hurricane Sandy until last year in 2017 for the Hurricane Harvey and Hurricane Irma. So it's a pretty old shark. Now we have to think about it, other kind of images and fake videos. For example, I talk about fake news. There are fake news, there are fake images, but can be all this news can be shared by, can be given by a fake anchor. A China television released this artificial intelligence anchor, realized with technique that Matthew showed before me. And so now we have to pay attention also to this kind of new threats that are the deep fake images and videos. It's a really challenging threat, so we need to think about it. And as a researcher, we already start to find some countermeasure to find a way to understand if it's possible to find this kind of forgery. Of course, images and video are related also on all the other kind of stuff, military propaganda and so on. And it's really important to understand and assess something about origin and originality also in this kind of domain. So now I would like to introduce this kind of research topic. It's kind of new. It's 15 years old, this kind of research topic, and is about to assess something about a digital media. So what we would like to do is to understand, given an image or video, two kind of things. There are two main topics about this. Understanding the origin, so which is the device that acquired that picture, and the other topic is about the integrity of that media, if is origin or not. The idea behind this is to find a digital fingerprint on the image, like a fingerprint, a real fingerprint of a person, because every time that an image go through a post-processing or the acquisition process itself can insert in the image some traces that can be exploited in some way to understand if something is happening in the image. So now if I start with some of the work that we have done in my lab during this past year. I can start with this case. There was this image on the web of this Syrian soldier, and it came out that this image was forged, and the photographer that shot this image was fired by the news agency because he violated the ethical rules of the news agency. With one of the techniques that we have at our lab to detect if an image is forged, it also localize the area involved in the forgery. This method is based on visual image descriptor, and it's based on visual characteristics and similarity. So it's possible with this tool to spot this kind of fake. Also, if you are a skilled photographer like the one that made this kind of forgery, because he many areas outside in the background was copy and move inside this area in order to hide something at this point, no? And actually it was like this because at the end the photographer released the image, the original image, and we were able to understand that it was hiding a video camera here. And it's possible to understand that it's really important, this kind of threat and this kind of forgery, because now it's really clear that here the meaning of this picture, that was the forgery one, the forged one, the meaning of this picture is completely changed now. If you see this video camera there, the photographer staged everything about this picture. So the weaponized information definition, it's really fit very well for this kind of cases. This technique is working also on printed images, so not only digital but also analog images, because it's working on visual characteristic of the image. We develop also an application for smartphone to spot this kind of forgery. For now, only Android based. It's really simple. You only need to take a picture of what you want to analyze, and the picture is sent to a secure server that made the analysis, and then you can give the answer after the analysis. And you can immediately or after a bit understand if the image is forged or not. We talk about, and Matthew talked about deep learning, no, for the generation of deepfake. Deep learning is used now for many things in many domains, from image and video classification, analysis of the scene, of the background, analysis of the object in an area, in a street. So why not to use deep learning also for image authentication? So our idea is to exploit this kind of technique to understand if there is a forgery inside an image. Because our idea is a little bit ambitious, because we would like to find a method able to be universal to any kind of attack. Because the attack performed by the photographer in the case before was related to a kind of attack that is called copy move. When a part of an image is copy and paste in the same image, but there are all the other kind of attack, like the spliced one, when you take another part of an image and then put in another image in order to create a composite of two parts. So to be more general as possible, we try to understand if it's possible to create a tool able to detect all this kind of forgery with deep learning. So the idea is like this. We have an image. We pass this image through a neural network. We try different models for the net. And then after that, the answer should be an image with some area that maybe is fake or not. So the output of the algorithm is the image is doctored or not, and where, like the example before. But in this case, the net should be able to understand if an image is forged, a patch of this image is forged, another patch is forged, and or maybe is original. We try different input to the net, from frequent input that are based on information related to some pre-processing to the image. So we guide a little bit the neural network in order to understand if the net is able to determine the differences between forged and not forged. Other inputs that we set was giving to the input RGB patches, so working on a special domain, giving the image like this and using the neural network as a black box, and let's see if it's able to determine these differences. Then we try a combination of the two in order to understand if it's possible for the net to improve the robustness in the detection using both inputs that I say you before. Here there are some results, and actually there are some improvement in using multi-domain CNN, so using both input to neural network. As I said before, there are two domains in image and video forensic. One is to understand if something is forged. The other one is understanding the origin of a media, understanding the digital camera that shot it, or if is acquired by a scanner or something else. But I introduce also that it's important to understand something about social network, because now more than ever, every images are on the net or are shared in a social network or social media platform. So it's important to understand also the social network of provenance of this kind of images. So our objective was, I have a bunch of images, can be shared everywhere in many times, in many social networks, and then are uploaded, downloaded many times. And so the objective is to classify these images in base of the social network of provenance. The motivation is very simple. We have billion of images sometimes to be analyzed when we have a suspect, and we collect all the hard disk, hard drive, pen drive, CD. So a forensic analyst have to analyze billion of images sometimes, only for one suspect. So to have a tool that automatically is able to distinguish which is the image that is coming from a certain social network can be very useful. Especially if the forensic analyst knows that you have that the images that he want to analyze is coming from Facebook, for example. So to have a tool that can analyze all the images that you have in all your hard drives, and say, yes, these images are from Facebook, can be really of help. We know that social network alter images when you upload the image on the platform, and do many things, and resize the image, recompress. Some social network can delete metadata, other no, there is a rename of the image. And every social network do different things when an image is uploaded. Our objective is to classify the images, as I already said, but without the use of side information, so without using EXIF information of JPEG images, or using the image size or the renaming. We want to exploit some inevitable traces that the social network introduce in the image, in order to understand if there is a fingerprint related to the social network. different traces can be exploited to do this in different domain. We use the DCT domain, the discrete cosine transform, to exploit the differences between social network. In this case, there is a graph that shows the histogram of this discrete cosine transform of one images that is uploaded on 3 different social networks: Facebook, Twitter, and Flickr. In this case, in this graph, and it's possible also with a look to understand there are some differences between this histogram on the 3 social networks. But to better exploit this kind of differences, we employ a convolutional neural network where as input there is this histogram of the DCT coefficient that can be able to discern between a social network and another one. And as input, we have all the K social network that we want to classify. And we come out with a final probability of that each patch in the image is belonging to a social network or another one. Here there are the different data sets that we try to understand if this technique is robust to many different data sets with different social network. For example, here we employ Facebook, Twitter, Google+, Instagram, and also 2 instant messaging applications like WhatsApp and Telegram. And also we evaluated also the original image that are not uploaded on social network. The data sets are really various. We evaluated also if an image is uploaded with different devices, Android and iPhone, and also if the image is uploaded through web application or through the smartphone application. Here there is some results on the data set that I explained you before with 5 social networks, 2 instant messaging application with 4 different smartphones. I think that it's working pretty well, but we need to improve. So there are some follow-up that we submitted to the ICAS conference next year. So it's a really fresh new work where we try to understand if it's possible not only to understand which is the last social network of the chain, but to understand the multiple image sharing. Because when you upload an image on a social network, this image can be uploaded and downloaded many times. You don't know how many times this step can be done. So this is one of our last work on this. And about new trends, so I would like to talk to you about the deepfake phenomenon. Matthew already talked about this. So the point is that deepfake want to the idea is to generate a video with audio or only with video of fake events. There exist many techniques in literature to do this. Some of them only swap faces. Other technique change the expression inside a video. So I think that there is really a big security issues on this topic, on this deepfake phenomena. So, and also there are other techniques able to generate photorealistic human faces with a particular kind of deep learning technique called generative adversarial network. They are really impressive. So how to counter this kind of video? Is a really pretty new research topic. So we start as community to study on this topic very, very recently. There exists in literature some frame-based method that study the video, dividing frame by frame and analyzing each frame separately. So it's kind of resorting to the problem that I showed you before about deep learning method to detect a forgery. We are working on another kind of technique able to deal with this kind of forgery based on temporal correlation on video. We study in particular this dataset that is one of the datasets available. I think it's only the only one now. So is face forensic dataset is called. Is generated with this technique that is called face-to-face facial reenactment algorithm that change expression in the person. So if a person have the mouth closed, they can change the expression open mouth. With a reference actor that doing the reference, of course. So the idea to counter this kind of video is to use temporal prediction in the video coding, so in the video compression, like the MPEG or the AVI compression algorithm. So what we want to do is to exploit differences in the fake video and the fake original, using the differences in predicted frame, and then exploiting these differences, calculating the energy on this error prediction. And then after that we define this kind of differences in energy, it's possible to employ convolutional neural network, or better to use some kind of network, for example, LSTM, that is able to capture dependencies in time of this kind of frame. So we take an image, we pre-processing this video to locate the face, then we extrapolated the error prediction, and then we give this error prediction to a LSTM to say, yes, this video is fake, or this video is original. Here there are some results on this energy prediction graph. You can, there are two videos, different videos, but you can appreciate the difference on this error prediction if the video is original and if the video is fake. These differences can be appreciated also by if you see by your eyes, but the network can do better. So we think that that can be exploited, this error prediction, as a good detector in deepfake videos. Another topic that I want to tackle here is adversarial machine learning. Why? Because deep learning is used to generate deepfake, is used to counter deepfake and to counter and to understand if an image is a fake or not. Is used in many other topics as image classification. But in turn, machine learning can be attacked. For example, exist many images that are called adversarial images that can be given to the input of a neural network in order to fool the net. In this case, for example, these images are adversarial, and if you have a content filtering that is able to find pedopornography images or images related to weapon or some violence or something like this, the net is not able anymore to recognize these images as pedopornography. So they fool the net, and then they pass the control of these images. You can understand that it's really a big threat, because now machine learning is used everywhere, and used also in sensible applications, security related, for content filtering, especially for content filtering, for terrorist propaganda images, porn, violence, and so on, and also in self-driving car, malware detection. So this is really a threat in a real-world scenario. And countermeasures on this are still missing. We need to verify more our model that on which our deep learning net are working. Exists some solution. I would like to show you one of them. Exists one solution. One of them is to include in the training phase of the net some adversarial images in order that the net can learn that there exists some adversarial image and can do something about this. Other technique can be to detect adversarial inputs. How? Let's come back again on the image that I showed you before. This is our example that are necessary to be filtered, no? And the net answer like this. So this is no more like this a gun, but it's a mouse trap. But our approach in this case is to successfully identify adversarial images, assigning low score here. So we can aware that this image is no more pedopornography, and yes, most probably is an adversarial image. So concluding, I would like to say that yes, there is an arms race between attacker and defender, and but who works in security know very well this problem, because it's the cat and mouse game of cybersecurity or security. So we have to deal with this. So the threat given by all these kind of new fake, like the fake or something like, or maybe something else that is coming in the future. As a researcher, we have to tackle this, and maybe we can tackle. I think with more research effort, project to deal with this kind of challenge. Of course, we need more collaboration. I think it is not a problem that can be solved by only technological solution, but it's a political and so on, so legislative problem. I think that only a cooperation, a collaboration on all of these entities can lead to solve this problem. Thank you very much. I conclude my presentation. Here there are the, thank you. Thank you. Thank you. Here there are all the references of the topic that I cover. If you want more information, you can send me an email and read the paper. Thank you very much.